Hi and welcome back to a follow-up video. You will remember Minisforum HX90. You might also remember the debacle from like Gamers Nexus, from my video that, yeah, there were some things missing and some things were not as intended. So for example, if you look at the outside shell, they were advertising carbon fiber, and at least me personally, I was expecting the typical carbon fiber you're used to from like the automotive sector. You have in your car, like the nice looking carbon. Turns out that they meant carbon fiber filled plastic. So it's just plastic with some carbon fibers inside. And yeah, I mean, this is just visual. So eventually I said, this is still, I mean, technically it might be okay to advertise this, but if you tell people it's carbon fiber and you have an image of this surface area right here, I told them this is still, to me, this is misleading marketing. But anyway, so I thought, let's just contact our friends from Tescan, which are doing scanning electron microscope analysis. Because with that, we could technically look inside the plastic and see if that's even true. So we're going to cut away one part of the shell and send it to Tescan. And then there's David from our community, German guy. Thank you very much, because he offered that he will provide his HX90. He got a retail unit just last week. So his should be one of the very first retail units of the HX90. Yeah, I mean, I ordered one myself after making the first video, and it's supposed to be shipped end October. So his will be much better, and it will be very interesting to see what they changed, if they changed anything, if the screws are different, and if they managed to apply liquid metal, and how it looks inside. Very curious. Fortunately, we will only need a very tiny piece of plastic for the scanning electron microscope. As you can see, I started cutting already to just see if this is easy to remove. I will cut one tiny piece out of the bottom shell right here, which is part of the entire like plastic piece going around the case. And then we will see what we will find inside. So this tiny piece here will be sent to Tescan.
Seasonic, the heart of your system.
We had some interesting developments over the past days. Well, first of all, you should check out a news video from Gamers Nexus. Steve found some very entertaining and interesting things in some videos that Miniforums posted on their own YouTube channel, because they posted some videos about like dropping tests of the units and how to disassemble the PC. Well, not completely, because you're obviously not supposed to take off the heatsink with the liquid metal and everything. We will do that, of course. But then, I mean, when they were first talking about the drop test, I was so close to perform a drop test myself, to just walk outside my apartment and just drop it on the floor, because they were talking about like 80 centimeters and 1.30 m height test, like dropping test. I was close to just dropping this on the concrete floor. I mean, when they first said they were doing like drop testing with this unit, and I looked at this and I was like, I mean, those edges, they still look perfect. How did they do the drop test? And then I thought about doing the drop test. Then we found out in the video that they did the drop test inside the packaging. It's good that we didn't do it. Otherwise, yeah, it wouldn't look that great, I guess. But we will pick up our third unit actually, because this is the unit from David, which we received. It's a retail unit. He bought directly from Minisforum. I hope that this will be like full retail status with updated screws, with the full liquid metal inside and everything. And then Minisforum, for whatever reason, sent a third unit to us, even actually without asking. But we will check that, see if things changed, if things improved. But let's just start with the retail unit we got from David. So thank you again very much for providing the retail unit. The only thing that basically changed are those Phillips screws. I mean, originally they used those annoying security torques, so they replaced this, which is great. And apart from that, I mean, we still have this fake carbon fiber visuals from the outside on all the sides, which we already saw in the original review. So just from the outside, cannot really tell anything. Going to open it up and then we check if there's like liquid metal spills or whatever. Underneath the cover, we can spot a 1 TB Western Digital Black, which should come from David. I don't think this was included. He also told me something about that. He ordered some like memory and SSD, so that should be his SSD. And just looking at the mounting frame, the backplate frame, whatever, of the CPU, this is definitely different from the first unit. So this is for sure different. They actually tell us that disassembly is prohibited. Yeah, we're not going to care about that. The first check regarding the case was good. So no spills of liquid metal, nothing. Yep, that's actually how it should be. So Minisforum also posted some videos online where they show assembly and disassembly of the cooler. Well, not really disassembly when it comes to like a guide, but they show how you could theoretically remove it, because they also glue the heatsink to the chip, which is a very weird way of mounting. I'm not sure why exactly they're doing that, but yeah, we will talk about that in a second. Also, the video of Minisforum is also quite funny in some regard, but we will get to that in a second. What they did is heating up the backside, simply to make it easier to remove the heatsink. I will just simply heat it from the front, and then the heatsink will be warm, and that should already help. Starting off with the heatsink, we have this sticky frame underneath, which is gluing together the heatsink and the chip, and we can spot the liquid metal in the center. One detail about this cooler is also different from my review unit, and you can see that there is a tiny elevation in the center. So this part in the middle, which makes contact with the chip itself, is elevated, which means they probably milled around here, probably also because they added the sticky tape, which is quite thick, and otherwise, if you would have this in between, that was one of my concerns, because I thought there's not that much space around it. So they changed the cooler in order to have enough space for the seal around it. We are inspecting the CPU with our macro lens. So first of all, we have the chip with the liquid metal in the center, and this is surrounded by a protective like frame, whatever. This is great. I mean, that alone would already work to seal off the liquid metal to make sure it's not leaking. What I recommended and what they also did is also shielding off the SMD caps by adding some kind of like protective glue stuff on top of it. Looks like protective paint, something like this. The only thing that is kind of bugging me is that on the left there's a single capacitor which is not covered by the glue, and also on the right side there is one single cap which is not covered on top by the glue. The rest is done well. So generally speaking, that's something you can absolutely do, to use liquid metal in mass production. Generally speaking also, this frame in the center already would be enough, even without like sealing off those SMD caps. Having the frame, sealing off the SMD caps, and I also want to add that, I mean, it looked like on the left and on the right, the top part of the SMD cap is not covered by the seal. And it's also possible, because this is very sticky, that this is sticking inside this stuff somewhere, like this, the part of this like sealant about this conformal coating. But yeah, I'm not quite sure why they even like sticked the heatsink itself to the CPU. That's not necessary. You could also just add a second foam frame totally around the chip, or even, that's what most of the people do, just have a part like this as a foam sticking to the heatsink and then stick it on top. It doesn't have to be sticky on here to seal it off. But yeah, I mean, this will work for sure. Looks good. Execution, I think it's done well. Also, the amount of liquid metal looks very good, and I think the temperatures will be all right. I'm going to check that now. Time to check the temperatures. So far, what we could see in idle was absolutely online and what was expected. Now let's check performance and temperatures under load. So that is absolutely lower than what we could see in our first review unit. I guess about 15 to 10 degrees Celsius less. At the end of R20, I'm expecting about 80 degrees Celsius because the heatsink slowly keeps heating up. But overall, this is a much better result than what we saw in the first PC. 5200 points as expected, so that's absolutely in line and far better than the first unit. So far so good. Just to be sure, we will also double check the second unit they sent to us. The second review sample also features the correct screws, no more security torques. Also checking the case itself, I couldn't find any kind of strange residues, any kind of liquid metal spills, whatever. And also PCB cooler, everything looks totally clean. Now going to remove the cooler and check what we can find underneath. I'm expecting that it's exactly the same as the retail unit, but we will check just to be sure. I'm very happy that I just damaged my review unit and not the unit from David. But apart from that, the like glue frame, whatever, came loose on the heatsink and just ripped apart a tiny bit. Everything looks good. The liquid metal amount looks good. The quality of the foam around the die itself looks decent. The only thing I noticed that also here the conformal coating is not the best quality, is not the most accurate. I guess it's because they do it by hand. It's still okay because it's like a level 2 security part and you don't really need it. Because of the foam frame itself, it would also still work without even a conformal coating, so I'm totally okay with that. I think I'm just going to remove the glue part on my unit, reassemble this, but this looks also good. Before we get into the material analysis of our plastic, we will first take a look at some screenshots I took from the Minisforum website. So the first one is taken on the 13th of September, where you can see on the bottom right the carbon fiber material. And if we switch to a screenshot from today, from the 27th of September, then you can see it changed to efficient heat dissipation. So that's already quite interesting. What I found more entertaining is taking a closer look at screenshots which I took from the bottom part of the product page with the carbon fiber material. So the first screenshot is taken on the 5th of September. That was prior to me and Steve publishing our videos regarding like the carbon fiber critics and everything, where obviously they stated the PC body is made from carbon fiber materials with grain designs on the surface, looks modern and agile, blah, blah, blah. So that's what we criticized, and after we published our videos, they changed it to carbon fiber composite materials. And they said part of the PC body is made from carbon fiber composite materials. Carbon fiber composite materials is not only rich in texture and delicate in hand, but also has very high strength, have very good thermal conductivity, blah, 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 and so on. So after I saw this, I was again in email contact with them and told them again that this is, even though they changed it, this is still misleading, because this still suggests to the end customer that you're getting some type of like carbon fiber. For example, this is part of a bike. I'm not sure what's called the handle of the bike basically. It's like a replacement part, and this is proper carbon. But this is still a carbon fiber reinforced plastic, CFPR. CFRP. But this is like 60% carbon fiber and like 40% matrix material, some kind of glue which keeps the fibers together. And that is what you would typically, that is what you would assume you would get if somebody is advertising carbon fiber. And since we all know that's not the case, and I told them again this is misleading, they changed it again. So they changed it, and this screenshot was taken on the 27th of September, and that is much closer to reality. They changed it to carbon fiber composite material, part of the product shell, except the bottom shell with 2 screw holes to mount the VESA mount is carbon fiber composite material, which is PC ABS, flame resistance and carbon fiber. It is carbon fiber reinforced plastic. It improves the strength of the product shell and also has good thermal conductivity and corrosion resistance. So basically it's just plastic with a small proportion of carbon fiber inside, which we will analyze in a second. What I still find kind of entertaining is that they're still advertising good thermal conductivity of plastic. We all know thermal conductivity of plastic is not great. Let's get to the analysis. Now I send our carbon ring as a reference to Tescan, and most of you might remember Tescan when we did a video last year about 14 nanometer versus 7 nanometer, analyzing some transistors inside the CPU. And Tescan, such an awesome company, and thank you very much for helping us out. So maybe if you're looking for your next scanning electron microscope to put it in your garage, then just buy it from them. Thank you. Anyway, so if you switch to the second page of our analysis, on the left side you can see an image of the chamber. Inside the chamber, on top you can see the carbon reference, so that's our ring, and on the bottom you can find the case polymer specimen, and on the right side this is just an image of how the Tescan Clara looks like, the SEM with the EDX built in. And EDX is basically using electrons that are hitting the surface, and then you have some X-rays being emitted from the surface, and this way you can determine what kind of atoms the part is made of. Now magnified on the left, our carbon ring, and if you pay closer attention to the bottom, you can see a scale which indicates the raw size of 2 mm on this specific size, and on the right side we can see the case polymer again on the same scale. For ideal comparison, Tescan performed some grinding on the surface just to be able to compare both specimens the same way. If we zoom in further, on the left side again the reference carbon, which is our carbon ring, and on the right side you can spot our case polymer. And also on the right side you can already see some white dots and also some of those yellow lines, and those are the carbon fibers inside the polymer. If we now switch to a different view, this is much more clear, especially if you compare left to right and pay attention to the white areas, which are the carbons or the carbon fibers. On the left, this is, as expected, about 60% carbon fiber, 60% white material, and about 40% the black material, which could be some kind of matrix material, some kind of glue sticking together the fibers. But now if you look on the right side, there's a lot of black stuff. There's not that much white stuff, which indicates that the amount of carbon fiber is very, very low. And this is confirmed if we switch to the Edx analysis. On the left side, we have a ton of those green spots, and the green spots mark carbon or the carbon fibers, and everything that is marked blue is oxygen, which indicates that it's the polymer. Especially if we switch to the right side, and you can see not that much green, not that much carbon, and a lot of blue stuff, it indicates, we don't have that much carbon inside the polymer. What I found interesting is that they even compared the carbon fiber itself. The carbon fiber reference from the left has about a 3 times higher carbon density than the carbon fiber on the right, which basically just indicates that it's lower density of carbon compared through the different carbon fiber materials. Doesn't necessarily mean a lot, but if we switch to the next view, to the Edx analysis, then you can spot that the right side only features about 3% of carbon fibers inside a polymer, whereas we have about, as expected, 60% carbon fiber on the left. So yeah, that is the end of the report from Tescan. So Tescan, thank you very much for this very nice analysis and for this very quick help on our matter. Yeah, 3% carbon fiber. For sure, 3% carbon fiber will still impact the plastic from a mechanical standpoint. It will still be tougher, it will be stronger to be used as a case material. I'm not going to argue about that, it will definitely help. And it's also typical, if you do some research, you can find anything between 0.5% carbon fiber to up to 15% carbon fiber in injection molded plastics. But advertising that it's increasing the thermal conductivity if you add 3% carbon fiber, I don't think so. And also, I mean, it wouldn't change anything. Even if you would mill this out of 100% gold or copper, which has a 20 times higher thermal conductivity, it wouldn't change anything. It thermally doesn't matter what your case is made of. And especially 3% carbon fiber is not going to have any kind of impact on your thermal performance. It will make the case probably more rigid, I guess. Not sure if that's even relevant. Not sure how many of you are planning to drop your case from the 5th floor. But I guess that's something you can advertise to make it stronger, but this is far from anything I would consider a carbon material. Technically, there is no straight definition what you can call a carbon fiber material, like a CFRP. There is no straight definition if you have to have X amount % of carbon fiber inside to be allowed to call it carbon. There is no such definition. So technically, they can probably call this carbon fiber material, but with 3%, I'm not sure how relevant this is. Generally speaking though, let's just recap. The liquid metal application is done very well. It has basically 3 levels of security, and already 1 should be enough. Just the foam ring around the die itself is usually enough to prevent any kind of liquid metal spills. Then they have the conformal coating around the SMD caps, and even if there's 1 cap exposed, since this is a level 2 security thing, it wouldn't really matter. And then they also glued the heatsink to the chip, which I'm not sure why they did it, but this will make sure that no matter if you drop it from your 5th floor, it will not spill liquid metal. So the liquid metal application is done well, But again, I'm not sure why they even use liquid metal. I mean, it's a 5900 HX, which doesn't have that much, it's not dissipating so much heat. The temperature usually, even with the conventional thermal compound, could be, I don't know, let it be 58 degrees Celsius, 90 degrees Celsius peak in Cinebench. How often are you going to perform Cinebench on such a thing? Probably never. And then the liquid metal will drop your temperatures by 10 degrees Celsius, but you need a lot of effort to be able to use the liquid metal. I'm not sure if it was the right choice to use liquid metal in there, because you cannot overclock the CPU anyway. Might have been better to just use a better heatsink, just increase the size of the heatsink a bit maybe, and this way maybe have the fan spinning lower instead of using liquid metal, just use polymer TIM, might have been easier. But just judging from the thermal performance, everything is fine. The whole marketing thing was just garbage, and yeah, I guess they learned from it. I hope so. All right. Thanks for tuning in. See you next time. Bye-bye.